Proof by cases. Sometimes there are many cases we need to consider with a direct proof. For example, prove that n to the third power plus n to the fifth power is an even integer for every natural number in n. So every natural number is either an odd or even. So therefore, we may consider two cases. So first, the n equals 2k. So any even number can be written as 2k. So then n cubed plus n to the fifth power, that will be 2k to the third power plus 2k to the fifth power. And then 2 to the third power, you get 8. And then you have k to the third power. 2 to the fifth power, you get 32, and k to the fifth power. So, but between a and 32, to illustrate this is an even number, we just need a multiple 2. So we factor 2, we get 4k to the third power plus 8k to the fifth power. This would be 16. So then this is in the format of like 2m, right? M will be this one. So this is a even number. And then let's consider n equals 2k plus 1, a odd number. So n to the third power plus n to the fifth power. So if you plug n equals 2k plus 1 into the third power and 2k plus 1 into the fifth power. So remember the formula a plus b to the third power. This will be a cubed plus 3a squared b plus 3a b squared, and then plus b cubed. A plus b to the fifth power. Remember this formula? That will be a to the fifth plus 5a to the fourth b plus 10a to the third b squared plus 10a squared b cubed plus 5ab to the fourth power and plus b to the fifth power. So therefore, 2k plus 1, apply this formula, so you will get a is like 2k, b is like 1. So this will be 2k to the third power plus 3 times 2k squared b plus 3 times 2k. b equals 1, so this will be 1. And then b is 1, so 1 cubed. So that will be applying this one. 2k plus 1 to the fifth power. So that will be, that's right here for more space. So this is like a 2k, b is 1, so this will be 2k to the fifth power. So therefore this will be 2k to the fifth power. And then this will be 5 times 2k to the fourth power. b is 1, so everything here is 1. You just focus on a only, right? So, and then plus 10 times 2k to the third power plus 10 times 2k squared, and then plus 5 times 2k, that we refer to this term, and then that will be b equals 1, so this is 1. So this one, you can write it as 8k cubed plus 6k squared plus 6k. Then over here, 2 to the fifth power is 32, k to the fifth power. 2 to the fourth power is 2 times 2 is 4, 4 times 4 is 16. 16 times 5, that is 80k to the 4th power. 2 to the 3rd power is 8. 8 times 10 is 80k cubed. This one, 2 squared is 4. 4 times 10 is 40k squared. And then this one, that's 10k. And now you have 1 and 1 here. So together you have 2. So this case is a little tedious. Now you can see everything here you can factor 2. So after you factor 2, you get 4k to the 3rd power. Just by factoring 2, you have 3. This one by factoring 2, you have 3. This one you have 16. This one you have 40. This one you have another 40. By factor 2, you have 20. This one you have 10k. And for 2, you still have 1. So you get 2 times this, and the whole thing here is an integer. So you have the format like 2 times m. Therefore, so m cubed plus n to the 5th power is even. So no matter n is odd or even, n to the 3rd power plus n to the 5th power, as we demonstrate, is always even. So this is the proof by cases. And before we go to next example, proof by cases, let's review about absolute values. Do you still remember absolute value? That like absolute value -2, that equals 2, right? Absolute value 2, that is also 2. So generally speaking, absolute value u, what do you get? If u is a positive number, like 2, you can simply drop absolute value. You just get 2. So if u is non-negative. What about if u is like a -2? So if u is -2, you cannot simply say absolute value u equals u. Because if u is -2, then this will be -2. But you want to get a positive number here. So to get positive, you may put minus here. So therefore, if u is a negative number, then you get -u. So this is about the absolute value. And for absolute value, we have this absolute value inequality. So absolute value of x plus y is less than equal to absolute value x plus absolute value y. This also another thing we need to review is absolute value u is less than p. This is equivalent to u is less than p greater than -p. So when we want to prove this one, this whole thing is like p. So therefore, you need to prove, so this whole thing is like a p, then x plus y is like a u. So that means, negative, if this is -p, then that would be negative absolute value x plus absolute value y, less than u, so that is x plus y, less than p, like this whole thing is p. So to prove this inequality, we need to prove this inequalities. So now let's look at different cases. Case 1. So what about both x and y are non-negative numbers? So x is greater than or equal to 0, y is greater than or equal to 0. So if both x and y are non-negative numbers, then x plus y is also non-negative, right? So if x plus y is positive, then if u is positive, it will be equal to u. So then the left-hand side here, that will be x plus y. Then it's just equal to x plus y because x plus y is positive. But since x is positive, so x equals absolute value x. Y is positive, then y is also equal to absolute value y. So we in case 1, x plus y x value actually is equal to x value x plus x value y. So we prove that in this case, and the inequality is true. Okay. Case 2, x is greater than 0, y is less than 0. So, and then we need to show this case. So negative absolute value x plus absolute value y is less than x plus y. We need to show this. To see this, and let's look at x plus y. So let's look at the right hand side. So x plus y, because y is less than 0, so x plus negative number, if you do not plus a negative number, it would be just x then. So x plus y is less than x because y is a negative number, so that will make the value smaller than x. And then you can also further think x is x, but y is less than 0, right? So x plus y is less than x plus 0. So x plus 0 is x, but because x is a positive number, so therefore it's equal to absolute value x. And absolute value x, of course, is less than absolute value x plus absolute value y. So we get this part. To show the other part, let's look at negative x plus y. So we take a distribution of negative, you get negative x plus negative y. So because x is positive, negative x is less than 0. And then, but negative y, because y is negative, so negative y is less than, negative y is equal to absolute value y. So therefore, this will be absolute value y. And then 0 is less than absolute value x. So now when two sides multiply by negative, this one you have negative, this one you don't. But if inequality multiplied by negative, then x plus y is greater than or equal to negative absolute value x plus absolute value y. So now you have this one, right? So in this case, you have x plus y is less than absolute value x plus absolute value y from here, from this one. And then you also this is greater than this one. So that is this one we talk about, right? We talk about this one. So that means absolute value x plus y is less than or equal to absolute value x plus absolute value y. So that's the second case. And then case 3, that will be x is less than 0, y is greater than or equal to 0. So just now with case 2, we have x is greater than or equal to 0, y is less than 0. And now you switch. So you switch. Now you see, by switching that, we can actually make a substitution to take advantage of case 2. So with that, capital X equals y, and capital Y equals x, and then apply case 2. So because absolute value x plus y now becomes x is capital Y, y is capital X. So this is still capital X plus y. So apply case 2, we did case 2, so we have this one in case 2. So that will be x is capital Y, y is capital X. So you have this one, and then you change x, y back. So y, you get x, and then you get y. So case 3 is also correct. And then case 4, the last one, x is less than 0, y is less than 0. Then x plus y is also less than 0. Therefore, absolute value x plus y, because x plus y is less than 0, so when you drop the absolute value, you get negative x plus y. By distribution, you have negative x plus negative y. Because negative x is less than 0, negative x will be greater than 0, so this will be absolute value x. Similarly, this one is greater than 0, so there will be absolute value x as well. So case 4, you get a quantity. So all the 4 cases together as a summary. Absolute value x plus y is less than absolute value x plus absolute value y. So this is another example. So for this example, you may also do a similar one. Prove that absolute value xy equals absolute value x times absolute value y. So you can do this, prove this one exactly in the same way as we just did for addition. And then another homework problem assignment is on page 59, number 8. Thank you.